Hey there, welcome to a new Algebra 2 video. I meant to do this, earlier, but somebody commented today on my 1.1 video and said thanks so much and to keep doing it, and so it made me really want to go ahead and keep doing it. So this is going to be section 1.2 for Algebra 2 from this book that I used a couple years ago. We're going to talk about characteristics of function graphs. So there's lots of things that we like to analyze on different types of functions, and since in Algebra 2 we're going to be looking at a whole bunch of different functions, this is a section kind of to introduce us to what all is it that we care about, what will we want to know when we're faced with a new type of function, and so it's going to be these things that we look at here. So here's some of the things that we want to look at when we're kind of analyzing functions. We want to think about over intervals, so this would be using like interval notation or inequality notation or something like that, and if you're not sure what those are, go back and check out my lesson 1.1 video, because we talk all about notation like that in that video. But we're going to be I'm going to use interval notation because it's my favorite and I think it's the easiest to write once you have the hang of it. But we're going to look at we have three graphs here that we're going to look at. Where are these graphs increasing, decreasing, and constant? That's our first chunk of things. Now, you can only be one of these three things. You cannot have a graph be increasing and decreasing at the same time. So when we're looking at those three things, we're talking about the idea of from left to right, is my graph going up, down, or is it staying constant? And hopefully just by looking at this first graph, it's kind of obvious what each part of this is doing. I purposely tried to make it obvious, at least the first couple sections of this, like what is happening, because, increasing, if that's the idea of going up and we're looking from left to right, well, that's this first section right here, right? This is increasing. So to write our interval notation, we need to figure out the x values that it's increasing between. So here it's starting at -4 and it ceases to increase here at -2 for x. And we choose just to use the x values because it makes it faster to write. And since it's a function, that means that we're guaranteed that using x values will be unique. What that means is that since this passes the vertical line test, if I'm talking about a section of the graph between -4 and -2 for x, I can only be talking about a certain part of my graph. There's not some other part of my graph that's like hanging out up here that I could get confused about which part am I talking about. There's only this one part from -4 to -2. Now there is kind of a weird thing related to increasing, decreasing, and constant. You would think that after all these years of doing this sort of thing, that mathematicians would all agree on, things, but they don't, because they're human beings, so we like to disagree about things. So there is actually more than one way that we could write this as far as whether or not there should be parentheses or brackets. There are some people who believe, and I'm one of those people, that because at the endpoints we can't really say we are increasing, decreasing, or constant. We're just kind of switching, like so here at this point right here at -2, am I increasing there? Am I constant there? Am I decreasing? What's happening there? I argue that I'm not doing any of them because that's a point where it's switching. So to me, as a math person, it makes the most sense, I feel like, to put parentheses whenever we do increasing, decreasing, or constant. But if you use brackets, because you're like, well, it is defined here, right? Like, it's not like there's open circles telling me that I can't have a value there. If you use brackets on increasing, decreasing, constant, it is technically right to do that, unless you actually do have some place where there's like an open circle saying that it's not defined there. And in that case, you would have to use parentheses. So my basically kind of PSA about it is that you will, if you're using parentheses only for increasing, decreasing, and constant, that's always right. And if your teacher disagrees, let me know and we'll prove them wrong. But if you choose to use brackets on increasing or decreasing or constant, you could end up being wrong at some point if you're not paying attention to where there might be an open dot or an asymptote or something like that. So I think it's safer just to use parentheses. Anyway, let's get back to what we're doing here. So it's increasing on this first section where we just have kind of this line going up. But then here at -2, our graph switches, and it stays doing the same thing until we get over here. This looks like 1, right? Because it's halfway between 0 and 2. So in between here, what would you say it's doing? Is this graph going up, going down, or is it staying at the same level? It's staying at the same level. So I'm going to put from -2 to 1, I'm going to list that under constant. And in case you were like, wait, you haven't listed all the parts where it's increasing, I'm just going to go from left to right on my graph and add to the appropriate kind of line. Because now at 1, we've got what kind of looks like a parabola, right? So this graph is going down from left to right until we get to this 2. So from 1 to 2, I would say it is decreasing. Now at 2, it starts going back up immediately, right? So from 2 to 3, it's increasing again. When we have more than one interval that we're saying together, this is what I have for increasing, we use this uppercase U for union, and it basically says that we're increasing from -4 to -2, and we're also increasing from 2 to 3. So both of those are places we're increasing. So we use that U, and we could end up with multiple parentheses for our intervals depending on just how wiggly our graph is. So if you were using the book that I used for this for Algebra 2, increasing, decreasing, and constant is likely to be a new thing that you haven't really done much with before, but domain and range is something we've seen before. Domain is the x values that this is defined for. So for our farthest left point here, our graph does not go beyond -4. For the farthest right, it does not go beyond 3. And everything between -4 and 3 is defined. There's no open circles between -4 and 3. There's no asymptotes causing us to kind of jump over a number. So this domain is going to be just one interval from -4 to 3. And because there's not open circles at the end there, we'd put brackets at -4 and 3. We have to basically, in order for us on domain and range to say that it's not equal to for domain or for range, we have to be like really sure that that's what's happening. So they either have to put an open circle, or we have to have an asymptote, or something that's saying, hey, it does not actually touch this point. That's not what's happening here. We don't have open circles. So we have to assume that like this point down here, -4, 1, -4, -1, we just have to kind of assume that that really is a point that is a part of our graph because they didn't tell us otherwise. So our domain here is bracket -4, comma 3. So that's our answer for domain. Our range is our y values. So our bottommost y value happens right here at this -1. And then our topmost y value is happening up here, both this constant area and this point over here, which are at 1. So the whole of this graph happens between the y values of -1 and +1. So that's our range. We've got another section of things we're going to answer about: positive, negative, and 0. Now, what this is basically saying is, where are the y values for this graph positive? Where are they negative and where are they 0? So our positive numbers are the things that are up here for y. So we're looking for intervals, basically, where we are positive. Then we're going to look at intervals where it's negative. And then we're also going to answer, okay, where are there zeros? And maybe that's the easiest question to answer, or the best question to answer first, because that's going to be these places where it's crossing the x-axis. And you've actually heard that term probably in Algebra 1. at some point, even if you didn't maybe pay attention to it, this idea that we have zeros of our graph are the places where our graph either goes through or touches the x-axis. So we have zeros at -3 and at 2. And since these are just like single values, that's why I'm choosing to write x equals -3 and x equals 2. It doesn't make sense to make these intervals since, you know, it's just a single number. It's not actually an interval. So the way this works then is that our positive values up here at the top where I've highlighted in yellow, those are going from this -3 right here to, now this is tricky. Now this is tricky. Our positives go to 2 where we've got a 0, and then from 2 to 3. Now we do have to break this up because at 2 it is not positive. So we're going to use interval notation. We're going to use parentheses because at -3 it's 0, which is not positive. So it doesn't make sense to use brackets here. So it's positive from -3 all the way to 2, and then it is still positive there from 2 to 3. But see, we're leaving 2 out, and sometimes this notation can seem kind of frustrating because these middle numbers here are both 2. So what we're saying when we do this is we're saying 2 is not included in this. But it's unfortunate with interval notation, we don't really have a shorter way of saying that. So then our negatives are just this first part of our graph from -4 to -3. And that's the idea of finding these things. We're going to do this again on the next one over here on the right, and then we're also going to do one more but add another concept in as well.
All right, let's look at this graph on the right. So we're going to answer the same questions: increasing, decreasing, constant, domain, range, positive, negative, and zeros. And this is doing kind of similar things in a way. We've got some places that we can see we'd consider constant, some places we would consider to be going up, some places we'd consider to be going down. And so we just need to kind of look for their x values. So I'm going to look here at this first section right here. I'm going to say, okay, that part is constant, and that's happening from -5 to -2. So in my blank for constant, I'm going to put -5, comma, -2. And again, you can use brackets here if you want to. It's okay to do that because our function doesn't have any open circles or asymptotes. So you're welcome to use brackets. I just prefer using parentheses. Then we want to do this next section. So from -2 to looks like 0 right here, it kind of switches to go down instead of going up. So this part right here, -2 to 0, should be in the increasing part. Okay, then at 0 we do take a sharp kind of dive down until we get right here to an x value of 3. So from 0 to 3 we are decreasing. And then we switch back here at the end from 3 to 5. We're constant again because it's not going up or down. So we're going to put a U that stands for union, and it's something we do when we have more than one interval that applies to the same thing. And then we put 3, 5. So that's our increasing, decreasing, and constant. Now our domain and range is going to be what are the x values that our graph has and what are the y values. So for domain, our farthest left x value right here is this -5. Our farthest right value is +5. And you also can kind of use what we did for increasing, decreasing, and constant, because the intervals that we were able to define for increasing and decreasing and constant should match our domain. We should have we kind of broke down our domain into these different areas. So I don't know if that makes sense, but our domain would be brackets because we don't have open circles at the end. We have to assume kind of that they're defined unless they tell us something that would make us think that it is not defined, like an open circle or having a sharp up or down that makes it look like an asymptote, which isn't happening here. So our domain is -5, 5. Our range, we're looking for our lowest point, which would be here at -3, and our highest point, which would be a y value of 6. So our range is -3, 6, also with brackets. Our positive, negative, and 0, just like on the one before. Now, this could be tricky because we don't actually, I didn't actually like show what this point is, which would have been super helpful. So we're just going to estimate that it's 2.5. If we knew the equation for this, we could figure out what that is by using our graphing calculator. But that was just kind of a lack of foresight, I guess, on my part. We have a 0 at approximately 2.5. And zeros are where we switch from positive to negative most of the time. Sometimes, like on the last one, we just are positive and then stay positive. But on this graph, we can see that this whole section up here, all of these y values are positive. Okay, that's what we are trying to define when we define where is this positive. So from -5 to 2.5, we are positive. And we could put a bracket around -5. So this is positive from -5 until we get to 2.5. But we're going to put a parentheses on 2.5 because it's not positive at 2.5. It is 0 at 2.5. So then this other part, which is our negative part down here, that's going to be from 2.5 to 5. And again, we'll put a bracket around the 5 because it is actually negative at 5. We were correct that -3 needs a parentheses because at -3 it's 0. And at 2 it needs parentheses. Alright, so the mistake I made here was at 3, which is over here, it is positive there. So we'd put a bracket. And the same thing here. -3, the parentheses was right. That's a terrible parentheses. Especially with parentheses and brackets, always erase instead of writing over if you make a mistake. But -4 right here, that is negative, so it should have had a bracket. So not as bad of a mistake as I thought it was, that I freaked out in the middle of that problem. But hopefully I haven't confused you too badly. I guess we'll find out. So those first two graphs were actually piecewise graphs. So I took pieces of different types of graphs and I actually put them together so that it kind of looked like one continuous graph. But this graph here is a polynomial graph, so it's a smooth curve, which is kind of cool. And I went ahead and picked out the points that are going to be helpful to us here so that we won't have to guess or things like that. We actually know what points it is we're going to use. And I've also added to this another thing we're going to find, which is called a maximum and a minimum. Graphs can have more than one of these, actually, maximums and minimums, and there's actually two types of maximum and minimums. One is called a local maximum or minimum, and the other is called a global, or I think there's another one as well, absolute. And so it's the idea of a local maximum or minimum is saying if I'm just kind of looking at part of my graph, a max would be where we have an up and down, and a min would be where we have a goes down and then comes back up. That would be a local max or min. Our global or absolute, depending on our book, our global max or min would be for this whole graph, what is the highest value or the lowest value. And we care about these for kind of different reasons. Like there's some cool things about local maxes and mins that makes us interested in those values, even if they aren't overall the highest or lowest values of the graph, like in this red graph that we have right here. So if it asks you to find all of the maxes and min, there's also another word we might use here. They call it extrema or extreme values, which is referring to maximums and minimums. And also the plural of maximum and minimum is maxima and minima, but you know what? I mess that up quite often. So what we want to do is kind of have this idea of we're looking for important points on our graph. So for this particular graph, it's an important thing that we have this up and down over here at -1, 1, and we have this up and down over here, or I mean down and up over here at 1, -1. Those are values that if we were modeling something in the real world, these would be values that would be important to us. And the same thing would be true about our zeros. Those are values that are likely to be important. We're going to go through all of these things, answering these questions. Our maximums and minimums are written a little bit differently than the other ones are, so we'll definitely talk about that in a second. So increasing here, we are going, remember we're looking left to right, so if we kind of follow this graph along, we start off with this graph going up until we get to this value up here of -1, 1. Remember, we just want the x value. So we are increasing. Well, where do we start? Since this is a polynomial, we kind of assume, I guess we could have put an arrow down here, we kind of assume it keeps doing the same thing forever. So we're actually increasing here from -infinity to -1. And then it starts going down, right? And it does that from -1 to +1. And then it turns around again and goes up. And again, it's like we have an arrow here because it's at the end of our graph, it's still continuing to go. So we would say, okay, well, from 1 to +infinity would be the other place where it's increasing. And there's not anything that is constant here. So we could say none or NA or something to say, hey, there's not any constants. And that should be true for most of our like standard functions that we actually have equations for. In order for us to have a constant, it's basically just like y equals 5 or graphs like that. That would be constant. If anytime we put in an x, we're going to end up with something that's not constant. So we have to actually try really hard to put constant parts in our graph. Now, our domain and range. So this is a polynomial, and we're saying it goes up and down forever. But that will help us with the range, right? We can kind of hopefully obviously see that, hey, this goes down forever, this goes up forever. So our range is -infinity to +infinity. But how about our domain? Is there anything that as we're going down also would stop us from going left or right? And the answer is no. As we're going down, we're going left. As we're going up, we're going right. So our domain is actually also all real numbers, or an interval notation, -infinity, +infinity. Our zeros here are some decimal numbers. I think this works out actually to be like, I think this is square root of 3 and negative square root of 3. But we have the decimals here, so we'll just put those. We have zeros at x equals -1.732 and at +1.732. And then let's look for our negatives and our positives. So this may be a thing where it is helpful to kind of highlight these, right? Because down here in the blue is where we're negative. Up here in the yellow is where I'm positive. So I want to do this section is negative. So from -infinity until we get to that 0 at -1.732, okay, that is negative. But then we switch, and from -1.732 to 0, now we are positive because we are above the x-axis. Positive means above the x-axis, negative means below. So -1.732 to 0. And then from 0 to 1.732, we're negative again. And then we switch back to positive, and that goes until infinity. So the new thing here is our maximums and our maxima and minima. So a maximum happens when we go up and come back down. This is a local maximum because this one for y, that is not the highest value that our function ever gets to, because our function continues going up forever. So we have a local maximum at, so the way, we'll write this different ways, and it may depend on your teacher how they want you to write it. One way is just to put the whole point, but another is to say we have a local max of 1 at x equals -1 or something like that. You'll see it written like that a lot. Our local minimum here is where we go down and then come back up. So we have a local min of -1 at x equals 1. And that's all of our maximums and minimums. Now, we didn't find the max and mins on the other ones because in order to make there be some interesting constants here, that can actually throw off this idea of maximums and minimums, which I've discovered the hard way before in the middle of class. So for instance, we could talk about on this first one, this local min right here. And we actually have an absolute minimum for this graph here because this is the absolutely lowest point of our graph. But as far as maximums go, I do not have a local max where I have kind of a turning point going up and then back down. And my max value does end up being this value of 1, which is happening a lot of places actually. So it feels weirder to try to write or analyze functions like this where we've got some constants. Here, this would be a local max. It would also be the absolute max. So it can be both. If you weren't sure that was the case, it can be both. It is a local maximum because it's going up and coming back down, but it also is the absolute maximum because it is literally the highest point. Right here we have an absolute minimum value of -3 down there at the bottom. So that's the idea of maxes and mins, and hopefully now you have a good idea of increasing, decreasing constant, domain, and range, and positive, negative, and zeros, and maxes and mins. And the important thing is to practice this if it's not quite making sense, to just keep doing more problems and seeing what the right answers are and seeing if they match up with what you think they should.
Hey, thanks so much for watching. I know there's some background noise throughout the whole thing because I was recording this with my son hanging out nearby, so hopefully it's not too distracting. If it is, let me know in the comments. I may try to re-record this or something. This is actually just part 1 of 1.2, so this was talking about the characteristics of function graphs like increasing, decreasing, constant, domain, range, positive, negative, zeros, maxes and mins. There's another thing in 1.2 that has to do with average rate of change, so I'm going to make that a separate video. If you liked this video, please hit the like button. If you didn't like it, just don't do anything. And then make sure you're subscribed and leave me a comment if you found this helpful or not. It's whatever. And check out my website if you haven't already, KStevMath.com. There's a link in the description. And I'm adding resources to that website all the time to help you learn math. So, thanks so much for watching. Bye!